All right, we have one more point of concurrency to talk about, and that's the point of concurrency of the altitude. Okay, so first we have to talk about, what an altitude is. Okay, so an altitude is that line is a perpendicular segment, okay, from the vertex to the opposite side. Okay, so it's perpendicular. Again, if you don't remember perpendicular, that's 90 degrees. It's a perpendicular segment from the vertex to the opposite side. Okay, and or the line containing the opposite side. And we'll talk about what that means in a minute. Okay, I just wanted to throw that out there so we have it, so we can discuss it here in a second. So altitude is a perpendicular segment from the vertex to the opposite side. So if I want to draw an altitude in, I need to draw a segment, like say from A, that would be perpendicular to BC over here. So I'm going to go ahead and I'm going to do a perpendicular. Okay, it's going to go from A and it's going to be perpendicular to there. So this is perpendicular, meaning it makes a nice 90 degree. Okay, so if I go ahead and I draw another altitude in, another perpendicular. Okay, let's go to B and be perpendicular to that one. Okay, now before I do the last one, what do we think? Is it going to be concurrent or not concurrent? Oh, it's concurrent. Okay, let's go ahead. Let's change the colors of these so that way we can talk about them. We'll stick with purple. Purple's kind of fun. Okay, so there's each of these is the altitude. And actually the altitude is only the segment. So it would be just from C to here, but it's kind of helpful to see the full line. Okay, so again, we're just looking at just this segment here that goes from here to here. So if we were to put points in, the altitude itself would just be the segment that goes from C to D to B, A to E. So we're just looking at those segments. Okay, so if we were to remove the lines, okay, we're just looking at those segments here. But again, those segments make a 90 degrees. Okay, and if you notice, they are all concurrent. They all intersect at this one point there, G. Okay, so they do have a point. The altitudes do have a point of concurrency. Okay, the point of concurrency is called an orthocenter. I know, a lot of vocabulary, right? So the point of concurrency of the altitudes is the orthocenter. The only thing that gets a little interesting with the orthocenter and the altitudes is the altitudes aren't always inside. Hey, I just want to go ahead and I want to switch the sky up and let's make it obtuse. Okay, all right, so we can't see what's going on here because we just have those segments. Okay, so let's bring those lines back. Look at where that point of concurrency is now. That point of concurrency is way the heck out here. This is where that, or the line containing the opposite side comes in, because if I was to draw this line in, do you see how this makes 90 degrees right here? And same with if I was to draw this line in, we make 90 degrees right here. So the altitude isn't always necessarily inside the triangle. Hey, if you have a right or obtuse, undo. Oh, sorry, I've got some notifications popping up. Okay, if I have an obtuse or a right triangle, these altitudes are going to occur outside. So to be able to draw those in, I'm going to have to extend the side of our triangles out, okay, to get those 90 degrees, okay, because our 90 degree is right there, and this 90 degree is right there. So as I move them, we can see, look, where's my orthocenter? My orthocenter is way up here, okay. Just depends on what type of triangle we have here. So then acute, then my orthocenter is nice inside the triangle, but as we get to right triangle, my orthocenter is at that vertice. Okay, but then it goes outside. You see my orthocenter's way down here now. Okay. Just because we have a obtuse angle there. Okay. One thing, the orthocenter isn't really as useful as all of our other points of concurrency because there's no theorem for it, right? We had a median theorem, we had a centroid theorem, we had a circumcenter theorem, in-center theorem. We don't have one for the orthocenter, okay? The orthocenter is simply just the point of concurrency of the altitudes, okay? That's really the gist of it there, okay?